Cool, here we go. 5.2. All right. When I get to earn interest on the principal and the interest, we call that compound interest, right? So my money is making me money, which could be a good thing. It could also work in a negative aspect. But compound interest formula is A, which is the final amount, is equal to P, which is the principal, which also means like the initial, like the starting amount, times parentheses 1 plus R divided by N, where R is the interest rate as a decimal. N is the number of times something compounds per year, and T is time in years. Number of times something compounds a year. Let's talk about that. That's where this little spot where it says notes comes in. If we are talking about money that is compounded annually, annually means how many times a year? 1. Yeah, happens 1 time a year. So how many times does that compound a year? That's going to give me an N value of 1. The word problems aren't going to give you an N value. You're going to have to deduce it from the information that they give you. So semi-annually, if we have a semi-annual sale, how many times does the sale happen a year? 2 times. So then N would be 2. And I'm going to write down a bunch here. It's not going to be an exhaustive list, right? It's not going to be every single word that they could use, but a lot of them. If you're a business owner, you very oftentimes do your taxes quarterly. And quarterly is going to mean 4 times a year. So N is the number of times it compounds per year. How many times a year does that happen based on these descriptors? If I do something monthly, if I give my dog a monthly medication, there's 12 months in a year, so that would mean N is 12. Do you guys know how many weeks are in a year? I don't know. Is this something you pay attention to? 40? No, how many? Isn't it what? It is in the 50s. 50? 52. Yes. It's actually the same number of cards in a deck of cards. 52. Cool. And daily would be 365 in a non-leap year. 365 days per year. All right. I tried to keep these word problems so that they weren't super full of words. Maybe a little more time to write down those notes. But I've got a word problem here and I have a chart. There's actually another row on here. On these word problems, I know you might not want to write down all of the words. If you want to just pick out the important information and just write that down, that's fine. But please don't write down nothing. Please at least write down the important information. Example 1, Sam takes out a small personal loan of $5,000 at a 4% interest rate. Find the balance after 3 years for the chart. And then copy down some version of that chart. This problem is designed to give us practice with money being compounded a different number of times without us writing out 4 different problems. So just a little extra practice with a little less writing. Cool. I've rewritten my formula there because I couldn't see it on my screen anymore, and I want to refer to it. And I'm going to go through for each one of these and talk about how many times the compound, what is the formula, and then calculate what is the amount of money. So, $5,000 personal loan, 4% interest rate, 3 years, all important information. But to start, if something compounds annually, we just talked about that means that it's going to compound 1 time a year. So n is 1. I'm going to go through, I'm going to fill in all the pertinent information. I'm looking for the final amount. That's my goal, is to find A. P is the principal amount, which is also known as the initial amount. So for that, I'm going to plug in 5,000. If you look back at the very top, the key says the R stands for the rate as a decimal. Right now, my rate is written as a percentage. So when I have 4% and I want to change that to a decimal, I'm going to move the decimal place over 2 places to the left. And my rate is going to be 0.4. That is where I see the most amount of mistakes on these types of problems. Just forgetting to move the decimal place. N is the number of times it compounds a year. That's 1, all to the power of 1 times t. And t is the number of years. All right, to be able to calculate this, we're going to need to remember our order of operations and utilize our calculator. Order of operations says I'm going to start with whatever's inside the parentheses. Well, I've got some parentheses, and parentheses have different meanings. What I want to do is right inside here where I have the 1 plus and a fraction, I want to simplify all of that first. 0.04 divided by 1 doesn't change anything. It's just 0.04. One plus 0.04 is 1.04. One times 3 in my exponent is just going to give me a 3. So I'm going to simplify from this point. After parentheses, I go to exponents. So I need to do 1.04 to the power of 3 before I multiply. So on your calculator, do that step, 1.04 to the power of 3. I like to copy down a bunch of the decimal places to start with, and then we'll cut it off later. Bless you. Using my handy dandy calculator, inside my parentheses, I get 1.124864. Then we'll take that and multiply by 5,000. In your calculator, that's best done by just doing times 5,000. You don't have to retype that number. My calculator gave me 2 decimal places. Since we're talking money, you're always going to round to 2 decimal places unless they tell you something else. Unless they say round to the nearest dollar or round to the nearest something else. So here we go. Sam takes out a small personal loan, $5,000 at 4% interest rate. After 3 years, now Sam is going to owe $5,624.32. Semi-annually means that this is going to compound 2 times in a year. So I'm going to plug it in much the same. I'm going to go a little quicker this time. What's going to change as I change n, the denominator inside the parentheses, and the exponents. Make sure you change both. All right, I've got n in 2 places in my formula. So order of operations inside those parentheses, I have choices to make also because I have 1 plus and I have a division. Do your division first. Inside the parentheses, I get 1.02. Raise that to the power of 6. Then we'll multiply that by 5,000. When I punched that in my calculator, I got 5,630.812096. There's more decimal places, but my calculator doesn't go anymore. I'm going to round to 2 decimal places again. So I have 81, and then I look at the 2. The 2 is not 5 or larger, so I just cut it off. And I get this number, slightly more, which makes sense. If my interest compounds more times, I'm going to have more money there. So I'm going to pause, and I would like you to do quarterly and monthly, and then just kind of look at the trend of what happens to A. So take a couple moments, compute the total amount for quarterly and monthly, use your order of operations, practice with your calculator, and then we can check together. If you didn't get the same answers that I got, that's okay, but let's figure out why. So, let's see. Quarterly, I plug in 4. This 1 is always a 1. It's part of my formula. So I have 5,000 times parentheses 1 plus my rate, which is still 4%, divided by n, which is 4, to the power of 4 times 3. So in your calculator, you got 0.04 divided by 4, which is 0.01. 1 plus 0.01. So I've got 1.01 to the power of 12. Final answer should be 5,634.13. Check your rounding. See how it worked out for you. And then for monthly, my final amount is $5,636.36. How'd they turn out? Do you need a little time to try to fix it? Not seeing any head nods that you need more time, so hopefully it worked out. If you have questions later because you'd rather ask independently, that's fine too. If you didn't get one of these right, maybe put a mark next to it and we can come back to it if you've got a question later and you want to ask later. Yes. 9,000? Ooh. That's a lot. 8,000? Right, so my n shows up in 2 different spots. It shows up in the denominator here and as the exponent here. Did you change them both? So then yours is a calculator problem. Okay, so on your calculator, 0.04 divided by 4. And on the way, that's the power. So what is the power of 12? That's the power of 12. And then times 5,000. Yeah, good. You got your mistake? Yes. Perfect. Awesome. Any other issues? Try it again with that number. I'll put the next section up here for you to start copying down, and I'll still walk around and help you. So if you're a little stuck, come give you a hand. So we just did compound interest formula, and now we're going to change this idea of continuously compound interest. Maybe you need help on a different problem.
Yeah. So one of the things that Ms. Thompson said was the most common mistake is you're forgetting to move your decimal over to. If you would put a 4 here instead of 0.04, and did the calculation, you'll come out with $157,312,967. And this is a great way of checking the reasonability of your answer. If you put in $5,000 into the bank and 3 years later you have $157 million, doesn't that beg the question of why isn't everyone a super millionaire? Right? So if you get a crazy answer like that, chances are you probably messed up here, but you definitely made some sort of calculator error somewhere. So make sure your answer is reasonable. Don't accept an unreasonable answer from your calculator.
So it's our second formula for today. It's a simplified formula, but it actually uses a new number that we're introducing today. I know that I've said it before, but I want to just say it again. Please get a good calculator, something that has more than one line. These are awesome. These are fantastic. It's a great Casio. These ones that I have, they're not very good. Don't get these ones. You just want something with multi-lines. For example 2, we're going to have 2 different examples, A and B. I'm going to do one with you, and then you're going to get a chance to do one, practice one solo. Again, if you don't want to write down all the words, just write down the important information. I tried to keep them pretty direct for you and not too wordy. So a continuously compounded interest formula, A is equal to P times E to the power of RT. E is not a variable. It does not change. It is a constant. It's always going to remain the same. Other famous irrational constants like pi, right? Pi is a number, has a value. It's always the same, doesn't change. E is a new constant that this is probably the first time you've seen it. A still stands for the final amount. P still stands for the principal amount. R still stands for the interest rate as a decimal. T still stands for time in years. What's happening here is instead of compounding interest 1 time a year, 2 times a year, 4 times a year, 12 times a year, however many times a year, it's constant. It never ever ends. It's just rolling, 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 rolling. This number should be on your calculator. You should have an E button somewhere. So on your calculator, search around. It should be a lowercase e. My calculator, when I find E, it automatically prompts me for an exponent. This calculator says e to the power of x. It'll automatically prompt me. I have to plug something in, so I'll plug in a 1. But I just want you to find your lowercase e on your calculator. And people's are going to be different, so help each other out. My button looks like this. So when I enter it to get the value of e, I'm going to enter an e to the first. And it's going to give me this value. So find it for me.
2.71828182845.
Oh, there you go.
E and I are on a first name basis.
If you need help, ask somebody next to you. If they can't help you, I will try. A lot of the single line calculators want the exponent before the base, which is why I don't love them. If you have a single line calculator, you need to hit 1, then e to the x, and it'll give you your number. You know, it's so convenient to use your phone, which works in a pinch. But when you take a test, you won't be able to use your phone, so you're going to need to know where that E button is on a calculator. All right, we're going to roll into example 2. We'll have more practice with finding E, so if you're still looking for it, we'll be around to help. Problem A, in 2020, you invested $12,600 at a 3.2% interest rate, which is compounded continuously. When it says compounded continuously, that tells me that I'm going to use this formula. How much do you have in 2032? So I know we haven't done this problem yet together or anything like it, but I want you just to take a minute and try to plug in everything you can plug in into the formula. You've got the formula. You've got a bunch of information here. Just plug in whatever you can. And if you make an error, that's okay. I don't mind you making mistakes. I just want you to try. You don't even have to do the calculator part yet if you don't want to. Just try to plug in all the pertinent information into this APERT formula. Give it a shot. If you're stuck and you're lost, ask somebody next to you for help. Maybe you guys can figure it out together. You're allowed to talk. Not only that, you're encouraged to talk. Yeah, maybe that's the difference.
Yeah.
If you got stuck, that's okay. I just appreciate you trying. A is the final amount. That's what I'm looking for at the end of 2032. P is the principal. That's the initial amount. That's how much I'm putting in to my investment in 2020. Or I guess past tense, how much I did. Please use a lowercase e. A capital E has a different meaning. I know, us math and science people were real particular. To the power of r times t. Hopefully you didn't plug in 3.2 for your rate. So I move my decimal place over twice and I get 0.032. And then time. How many years have passed between 2020 and 2032? So don't plug in the actual year. It should be 18,000. So don't plug in the actual year. How much time has passed? How many years have passed from 2020 to 2032? My time should be 12 years. So just see, did you get the 12,600 in the right spot? Do you have a lowercase e? Do you have 0.032 for your rate? Do you have 12 for your year? If you miss a piece of it, that's okay, fix it. And then we get to do the calculator portion. Order of operations, I need to raise e to this power. Some of your calculators will do a really good job putting this in the exponent if you have a multi-line. If you have a single line calculator, you've got to do it in steps. You have to do the multiplication first and then e to the power of this. So 0.032 times 12. If you've got to do it step by step. And then I have to raise e to the power of that. You get some irrational number, it doesn't end, even though my calculator only shows like 9 decimal places or whatever, there's more to it. I will always use the exact figure if I can. If my calculator is giving me 1.468145442, blah, blah, it keeps going, you just can't see it. Then I'm just going to hit times 12,600 so that I can keep it as exact as possible. The sooner you round, the bigger your error is going to be. So punch it in your calculator to make sure that your calculator is being used properly. And if you're in the ballpark of 18,000, you're close, but it should be $18,498.63. Cool. I'm going to put the next problem up there. This one's for you to try. If you're still stuck on A because you're having calculator issues, get my attention. I'll come help you. Otherwise, try B. Yes. Okay. Just missed a number. Digits. It's not times you need e to the power of. Raising something to the exponent is not the same thing. So to the power of 1. Just try to first. So in here, you're going to do power of times 12. Again, if you have a single line calculator, you have to do the exponent and then e. It's not beautiful. It's not my favorite. Everything else you have is in the right spot. You're going to know you're in the right ballpark if you've got 519,000. It's going to like quadruple. Okay. That's great. If you didn't get anything close to that, if your number's mondo, I wrote the formula up here. You could check your work. Yes, with a dollar sign.
Kind of like what I said before, where if you get a really large number, you should ask yourself if it's reasonable. 500,000 is definitely reasonable here because we started with 125,000 and we're going out 30 years. The more years you go, the bigger the number gets, just like your exponential graphs you did earlier in the week. It's going to get big fast over a longer period of time.
Okay, final answer and solution is up there. Now, you may have all of these steps written out. You may have skipped some steps. It kind of depends on how good you are at your calculator and that kind of calculator that you have on if you can do everything at once or if you have to break it up into smaller steps. But the answer should be $519,732.23. So I know some of you guys are still working on this, and that's totally cool. I'm going to talk about something related, but that's not exactly in the notes. So if you're working on this problem, keep working on this problem. To kind of try to wrap your mind around this, I know you guys were like small children at this point, right? But maybe you've heard your parents talk about it. When we hit a huge recession in 2008, it was because people's home loans had gotten way out of control. So they were writing these loans for people at really, really high interest rates and variable interest rates, and people were getting stuck in a hole. And this is what was happening. Now, you don't really buy a house in California for $125,000. Maybe like a mobile home, something really small, or maybe something kind of really not in this area, like more rural. But all across the country, people were buying houses for these not so expensive amounts of money, but they were getting these variable loans or these really high interest rates. And so what happens after 30 years on $125,000 is you end up owing over $500,000. So people were ending up in these huge holes. Now imagine you buy like a $300,000 house, right? Or how much you going to owe at the end of 30 years? Astronomical amount of money. So people were getting in these really big holes, and it definitely had something to do with the huge recession that we hit when you guys were like, you were like 6 or something? How old were you in 2008? 3? Oh, you guys are getting younger and younger. Yeah, so maybe you've heard about it. You most definitely probably don't remember it. But that's kind of what happened is people were getting into these high interest rates with these deals that they thought were going to suit them really well, and it just ended up blowing up in a lot of people's faces. A lot of companies went bankrupt because they couldn't pay their loans. People went bankrupt because they couldn't pay their mortgages. It was kind of it was bad.
The lenders knew what they were doing and built up all of these things and then sold them to unsuspecting other banks that thought that they were good loans. And the banks that made all of these loans made out with a bunch of money and even bankrupted the country of Iceland. It was bad.
It was bad. Cool. So just a little background for you. Example 3, we're going to do one more type of problem, and then we're going to wrap it up for today. So I've got 2 of these on here. Write an exponential model. Remember, we talked about when it says write an exponential model, it's just looking for an equation. Don't be thrown. Given 2 points. Write an exponential model given 2 points, and the 2 points that I'm going to start off with are 12, 20 and 13, 23. Jot that down. I'm going to navigate away from this page real quick just to give you a short reminder. If you don't have this down, don't fear. I'm going to come right back to it. to take a peek at what we talked about at the very beginning of Monday when we were looking at 5.1. In 5.1, we kind of had a review of comparing what do linear, quadratic, and exponential models look like. We looked at the formulas, we looked at the equations, and we looked at the tables. I'm sorry, that was redundant. We looked at the formulas, we looked at the graphs, and we looked at the tables. When we looked at the tables, we talked about when we have a linear function, we have a common difference. We have a quadratic function, we have a common second difference. But things kind of change when I go to an exponential model and I have a common ratio. This common ratio is the b value. So this value of 3 is the b value for my exponential model. The common ratio that I find goes here. So when I come back to what we're talking about now, I want to find that common ratio. Well, here, my values are 12 and 20, 13 and 26. The numbers provided, my x values are sequential. That makes life easier. But I want to know what is my common ratio here. I take 20 and I multiply by what to get 26? I'm going to write an equation. This isn't like the absolute only way to do this, but I think it makes sense. I want to know 20 times what is 26? What is that common ratio? What am I multiplying by to get to the next number? So to solve for b, if you will, I'll divide both sides by 20. And I get a b value of 1.3. Now, are there other ways to do that? Yes. You could sit there with your calculator and you could do 20 times what is 26, and you could play around and you could just do some guess and check. You could also just take 26 divided by 20. But I like this little, I don't know, when I set up a little formula, sometimes it's just nice to like really see it very clearly. My goal is to write an exponential model. Boom, y is equal to a times b to the x. I know b. Awesome. Let's plug that in. When I'm writing an equation, we know that we only want the variables of the input x and the output y. So I still got to find a. We've done this with different types of functions before. I know it could be fuzzy. That's okay. It's one of the cool things about Math 3 is we have this constant review of ideas as we look at all these different kinds of functions. But I can find this a value by plugging in some point for x, y, finding a, and then writing my equation at the end. Well, oh look, I have some x, y, I have some coordinates to choose from. I could use 12 and 20, or I could use 13 and 26. Your choice. I don't know which one you like better. I think I like 12 and 20 better. But you could use the other one and still it'll work out. So I'm going to temporarily plug in x and y so I can find a, and then write that at the end. So y is 20. I'm looking for a. I know b is 1.3. That's my growth factor because it's greater than 1. And then x is 12. Oh, yes. Order of operations with exponents. We've been practicing. To solve for a, I want to do this operation 1.3 to the power of 12 first, and then I'll divide by it. What is 1.3 to the power of 12? Something I don't want to do in my head. Thank goodness for handy dandy calculators. Now there's a whole bunch of decimal points there. I'm not going to write them all down, but I am going to use all of them in my calculator. To get A by itself, I have A times 23.29808512, blah, 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 blah. So I'm going to divide by that number. In your calculator, remember you want to divide by the whole thing. So you just do 20 divided by the answer. Now, I think all calculators, or at least all of the ones that I've used, always have an answer button. So you can basically copy that last line without having to retype it all. It's a very useful tool. It will save you some time and energy. So in my calculator, I'm going to do 20 divided by my answer. I could just copy the answer from the previous line instead of retyping it all. So if you want to hunt for that feature, this problem does not specify how many decimal points to round to. Your Savas homework probably will. We're going to go ahead and we're going to round to 3 decimal places. If it doesn't tell me and if it's not money, I always default to 3. 858. All right, and one last step, and then we'll kind of review what I did here. So my goal was to write this exponential equation. So my A is 0.858 about. We found B is 1.3 to the power of X. Ooh, excuse me. Stop. Whew. Okay. I'm going to go over my process again and explain it again, and then I'll give you a few minutes to try the next problem. So the first thing I set out to do was find B. I like to make a little table and ask myself, okay, so B is my common ratio. The previous y times what gives me the next y. So you can just do 26 divided by 20, or I could do 20 times B is 26 and solve this little equation. I get 1.3 for B. I can plug that in and that's all fine and dandy, but I still need to find A. It's the only other variable besides x and y. So I'll plug in some point for x, y, and then solving. The tough part here is just the order of operations. So I pick a point to plug in. You could pick in the first point or the second point, doesn't matter. You get the same answer. So I plugged in 12 for x and 20 for y. Do this calculation, 1.3 to the power of 12. And then I want to divide by it. That gives me some value of A. For my final answer, I want A as a number and B as a number, because x and y will be my only variables. So the first thing you're going to do for the next problem is find B. So start there. See if you can use this as a guide to work through the rest of the problem. starting from here. So starting from there, it's going near. Snowball. B should be 1.25 before you get too far. If you got to this point, and then what you need to do is you need to take one of the coordinates and plug it in for x, y. You should get an A value of 6 point something. So you know you're on the right track. No? Oh.
Is it 1.25 or 0.0125? We've already said 32
Okay, rounded. So here, when I rounded 3 decimal places, I look at 41, it's 3 to 5. Real specific, but 6.711 is a correct round thing. Yeah, that's really good. So you could plug in 7 and 32, or you could plug in 8 and 40. They'll give you the same answer. I'm just going to pick 7 and 32. That's what I saw more people do. So I plug a 7 in for x, the 32 in for y. This calculation, 1.25 to the power of 7. It's different than times 7. To make sure you're using the correct operation. If I jot down about what that is from my calculator, it's 4.768 something. And then I'm going to divide both sides by that. Now, please use the exact numbers in your calculator. Try not to round too much, because your answers will become off. When I take my A value and I round to 3 decimal places, remember I always check the 4th decimal place to see what that does to the 3rd. So 6.7108, the 8 will round the 0 up to 1. So if I round correctly, for my A value, I get 6.711. And all I'm doing here is writing an equation. I'm not evaluating anything. So I get A times b to the power of x. Woo! And that wraps up 5